Oh man, you guys are ready for these problems. These are going to be some doozies. Example 8, 9. So these are going to combining everything we talked about in this section so far, which is really cool. And it will combine things from this section as well as previous sections. So brace yourself. So what we have here, you guys, we have an equation or a polynomial in standard form. Okay, and what we're going to do is we're going to write this equation or this polynomial in factored form. And we're going to be able to do it based on this graph. Okay, so we have to have the graph until I teach you something new, which that will be later on, so you'll have to wait for it. But as of right now, the only way to get from standard form to factored form, okay, we have to have a graph because sometimes we cannot use the factoring techniques that I taught you about. So sometimes we are limited by those factoring techniques. But if we have a graph, there's a quicker way to get this thing in factored form, even quicker than the factoring techniques I taught you. So brace yourself. Okay, so we're going to answer some questions based on the standard form as well as the graph. And then after we get it into factored form, we're going to be answering some nifty questions about our factored form. So get excited, you guys. Okay, so the first thing, when we do this, we're going to find the zeros from the graph, which the zeros are the x-intercepts on the graph. And for these, you guys, we're going to assume that all the zeros are real because we can only see real zeros on the graph. We cannot see imaginary zeros. Now, later on, I'm going to teach you a technique on how to find all kinds of zeros. So real zeros and imaginary, even when you don't have a graph, and even when you cannot factor your polynomial. So we will talk about that later. You'll have to wait for that. Okay, so the zeros on my graph, where this graph smacks the x-axis, it smacks it at -5 and at +4. Okay, so my zeros are x equals -5 and x equals +4. So x equals -5 and x equals 4. Those are my zeros. Are the leading coefficient in standard form, which it currently is in. Okay, we pick the number that is with the variable with the highest exponent. So my highest exponent is to the third power. Okay, so the coefficient associated with that is -2. Alright, you guys, so we're going to be finding factored form through synthetic division, okay? Which we already know, since our leading coefficient is -2, I'm going to write this at the bottom where our answer will be. I know that -2 is my leading coefficient, and remember, you guys, in factored form, that's the very first thing you see in front of some parentheses, which currently I don't know how many parentheses I'll have. I'm just going to put 2 here because I have a good feeling we'll have 2 parentheses. Okay, of some sort, and I'm going to put x's in there because in factored form we always have x's in the parentheses. Okay, so right when you find your leading coefficient, I would go ahead and write up your final answer and kind of put that at the very front so we don't forget about it. A lot of people forget about their leading coefficient, so be careful. Alrighty, so what we're going to do, you guys, the first thing, what we're going to do before we start doing synthetic division, we must always factor out the GCF first. If there is a GCF, we must factor it out. So looking here, okay, I'm going to look at the variables first, which I do not have an x in each term, which means I cannot factor out an x, but I do see a 2, a 12, a 30, and a 200. Okay, so the thing that goes into 2, 12, 30, and 200 is 2. Okay, but also, you guys, we don't want negatives in the very first term. Okay, when we start writing factored form, if we have a negative left over, it's going to cause problems. Okay, so 2 does go into 2, 12, 30, and 200, but I'm also going to factor out a negative number because we do not want that first term to be negative when we start doing our synthetic division. Alright, so I'm going to factor out my -2. So I'm going to rewrite standard form up here, or right here. Alright, I'm going to factor out our GCF, which is a -2. Holy hot dog. I'm excited. Alright, so -2. I'm going to divide all these by -2. Bam! And bam! Alright, which I forgot my y equals. Man. Get it together, Miss Long. Y equals -2. Alright, and what's left over? Negative 2 divided by negative 2 will cancel out, so I'm left with x to the third. Negative 12 divided by negative 2 is 6, so I'm left with a positive 6x squared. 30 divided by negative 2 is negative 15, so it'll be minus 15x, because I have nothing to divide the x to. And 200 divided by negative 2 is negative 100. Alright, so again, when we do synthetic division, we don't want that first number to be a negative or it will cause us issues. Okay, so when we're doing this, you guys, what we're going to do, we're going to do synthetic division, which will reduce our equation down smaller and smaller each time until we can get it in factored form. Okay, and what we put in our little box when we do synthetic division are our zeros. Now, looking at the graph, this is going to help us figure out how many times we need to put numbers in the box. Okay, so if we see here, at the graph right here kind of comes down and bounces off the 0. So I know at negative 5, the graph is tangent, which means it has an even multiplicity. Okay, so I know that I'm going to have to use negative 5 at least 2 times because it's even. Okay, because it's tangent at the 0. Okay, it comes down and bounces off, which means it has even multiplicity. Now this one just crosses through the graph. So it crosses through, which means it has an odd multiplicity. Alright, so I know that this one has to hit at least, or it has to have at least 2 zeros at negative 5 because it has an even multiplicity. So I know on one of these it's an even exponent. So one of my parentheses will have an even exponent and the other one will have an odd. And something else to consider, you guys. What is the degree of this polynomial? Holy hot dog, you guys are so smart. Okay, the degree, or my highest exponent, is a 3. Okay, so my degree is 3, which means I can have at most 3 zeros. Okay, so sometimes, you guys, we can kind of figure this out. If I have up to 3 zeros, and one of the zeros has an even exponent, and one of them has an odd, I can already figure out, because remember, in factored form, the degree, we add up the multiplicity. So, I can already kind of know that at negative 5, the multiplicity is going to be 2, and this one's going to be 1 because the degree is 3, and 2 plus 1 will give me 3. Okay, so I secretly already know, I already kind of know what it is. Okay, I already know that one of my exponents is 2, and one of them is 1, and I know at negative 5, it's the even one. So I already know that this is like x plus 5. And I already know, you guys, that this is x minus 4. Because remember, in factored form, we do the opposite of the zeros. So my zeros are negative 5 and positive 4. So in here, it's going to be positive 5 and negative 4, the opposites of these. Okay, so technically, I already know what factored form is. Okay, I don't even have to do synthetic division to get there because I can reason through it on the graph. Now, sometimes, though, you cannot do that. So I am going to show you the synthetic division process because we cannot always kind of predict it at the start. Okay? So, anyways, back to synthetic division. So, I'm going to show you how to reduce this standard form right here, this parentheses, down to these 2 parentheses. It's going to be epic. Okay? And so, after we factored out the GCF, what we're going to do? We're going to do synthetic division, and we're going to be putting our zeros in the boxes. Okay, which it does not matter which one you put in there. I'm going to start with 4. What? Might as well, right? Okay, so I'm going to start with 4 in my little boxy. So again, in the box, we put our zeros. That's what goes in the box. Alright, and I'm going to do synthetic division with this right here. So, my highest exponent is x to the third. Then I have an x squared. Then an x to the first. Then an x to the 0. Alright, as the number in front of x to the third is 1. The number in front of x squared is 6. The number in front of x is negative 15. And the number that doesn't have the variable, which is our constant term, is negative 100. Alright guys, let's do this thing. Alright, I'm going to bring down my 1. I'm going to multiply my 1 to the boxy. 1 times 4 is 4. I'm going to slide it on over. 6 plus 4 is 10. I'm going to multiply this to my boxy. 10 times 4 is 40. I'm going to subtract. So 40 minus 15 will give me a 25. 25 times 4 is 100. Holy hot dog, you guys. So negative 100 plus 100 is 0, which that makes complete sense, you guys, because remember, when we're talking about if something's a factor, remember the remainder is 0, which we already know that x minus 4 is a factor. We already know. So our remainder should be 0. So guys, when you put the zeros in the boxy, your remainder should always be 0. If it's not, you did something wrong. So watch yourself. Okay, so what I'm going to do, you guys, I'm going to keep reducing this down over and over. Okay, so now what I have is, okay, I'm going to basically write this again. So I'm going to start with my leading coefficient, which is negative 2. But then, instead of writing this, I'm going to write my depressed equation in my parenthesis, or I'm going to write the quotient. Okay, this right here, what we get after we do synthetic division, is called our depressed equation because it's smaller, and I guess it's sad, apparently. Okay, so what's left over, you guys, our quotient. My highest exponent was x to the third, so now, since we divided, we get smaller, so we start with 1 less than our highest exponent, which is x squared. So it'd be 1x squared plus, and then remember we go down by 1 each time, so plus 10x plus 25. Alright, so we're getting close. Okay, and also you guys, since this one worked, it is one of our factors. Okay, so this is the 0, so in factored form, okay, this is going to be the opposite of it. Remember, factored form is the opposite of the 0. So this will be x minus 4. Okay, so I wrote my leading coefficient. I wrote my reduced equation, or my depressed equation, which is my quotient, and then I wrote the factor, since this was a factor, because we got a remainder of 0. Alright, so now what we're going to do, using our depressed equation, or what was left over, so this. We're going to keep going with synthetic. I'm only going to use these numbers, and now I'm going to put another 0 in the box. Okay, so I used 4 already, so now I'm going to go on to negative 5. Okay, so my zeros go in the box, so I put my negative 5. Okay, I'm using these numbers now. So my highest exponent is x squared. So x squared, x to the first, and x to the 0. Alright guys, let's do this. So the number in front of x squared is a 1, the number in front of x is a 10, and the number in front of, or the number without the variable is 25. Alright, let's do our synthetic division. Bring down the 1. Multiply this to the boxy. 1 times negative 5 is negative 5. Slide it up there. Add down. 10 minus 5 is 5. I'm going to multiply this to the boxy, and 5 times negative 5 is negative 25, which you guys should be seeing a pattern. Alright, 25 minus 25 cancels out and turns to 0, which makes sense because this is supposed to be a factor. We already know, because we already know from the graph it's a 0. It hits the x-axis at negative 5. Okay, so what we are left with, you guys, this is our final answer, and I'll explain why. Okay, what we write our previous leading coefficient, our previous factor. We do not write the equation we use synthetic division. We never write it again. Okay, so let's see where I can squeeze this in. I'm going to squeeze it. I'll kind of write it below the answer since I'm out of space. Okay, so I'm going to bring down my leading coefficient, my negative 2. I'm going to bring down the factor that we got last time, which is x minus 4. Since we just found this factor, you guys, I'm going to write it next. Which, remember, this is the 0. Okay, so we have to write the opposite sign since it's factored form. So I have x plus 5. So we write the opposite of this in here. And then we write our depressed equation. So what's left over? So since I started with an x squared, we start with 1 less in here. So I have 1 x to the first. X to the first is 1 less than x squared. And then I have a positive 5, so plus 5. Alright, so let's talk about why this is equal to that. Okay, so I have a negative 2, I have my x minus 4, and I have 2x plus 5. So a shorter way to write this is with a squared, because x plus 5 times x plus 5 is x plus 5 squared. Okay, so we did end up with the same answer, which is super exciting. Holy hot dog, you guys. So this would be my final answer in factored form. Isn't that exciting, you guys? Look at all that work we did to get it to factored form. Holy hot dog, you guys. Awesome. Alright, so now, we're going to answer these questions about factored form. So the leading coefficient in factored form is that first number we see in front of the parenthesis, which is -2. Okay, which if you see, this is the same thing as the leading coefficient up here. It should be, or we did something wrong. All right, the zeros, remember we changed the signs in factored form. So since it's x plus 5 here, it's x equals -5 here. And since this is -4 here, it'll be +4 here. Which, holy hot dog, you guys, we have the same thing listed up here. So we're on a roll. We're good to go. All right, the multiplicity are the exponents on each of these. So the multiplicity on this one, the exponent that pertains to this 0, x equals -5, is this one. And the exponent is 2. All right, and the multiplicity on this one, the factor that pertains to x equals 4 is x minus 4, and the exponent is 1. All right, so now it wants the behavior on the 0, which what that is, you guys. Is it tangent or does it cross through? So since this is an even number, it should be tangent at -5, which, holy hot dog, we already said that up there at -5 is tangent. And since this exponent is an odd number, it will cross through. So on the graph, it should cross through at the 0, which we said that up here at 4, it did cross through. Holy hot dog, right? And finally, you guys, the degree, we add up the exponents. So 2 plus 1 equals 3, which, if you see here, the degree in standard form is our highest exponent, which is a 3. So yay, it all worked out. Wasn't that exciting, you guys? I had a blast. I know you guys did too. Don't even lie. I know you did.